Hi, I'm Dr. Christopher Sutton. Welcome back to my Introduction to GIS video series. In this set of videos, we will examine analysis of vector GIS data. We will begin with preprocessing techniques, and will follow with videos covering proximity operations and overlay operations. Preprocessing techniques are operations that are performed before any spatial analysis can be done. Such techniques are essential for preparing vector data for analysis, ensuring data accuracy and usability. Preprocessing techniques are used to fix errors before doing analysis. What are the various preprocessing techniques that are commonly done? We'll begin with data cleaning. Data cleaning involves correcting errors and inconsistencies in vector datasets. It can involve removing duplicates, duplicate points or lines, or duplicate records in the attribute table. It can involve dealing with invalid geometries, self-intersections, or ring overlaps. And it can involve removing zero-length lines and zero-area polygons. With these features, you have vertices all occupying the same location. There are topological corrections that are done. Topology in GIS refers to the spatial relationships between vector features that must be maintained for data integrity. Topological correctness ensures that spatial analyses produce valid and consistent results. Common topology errors that must be addressed include gaps, which are spaces between polygons that should be adjacent. Overlaps, where we have polygons covering the same space. Sliver polygons, where we have narrow, unwanted polygons that result from imperfect boundaries. And dangling nodes, lines that do not connect to others when they should. A lot of preprocessing can involve attribute data management, where we're managing the non-spatial data tied to the vector features. We may perform field calculations where we create new attribute fields or update existing ones using calculations and expressions. We might remove redundant fields where we have multiple fields that are portraying the same information. And we might deal with domain enforcement where we ensure all attribute values fall within valid categories. Coordinate system alignment is also very important as it ensures spatial consistency between datasets. Such preprocessing can involve assigning coordinate systems to a vector data layer or reprojecting a data layer from one coordinate system to another so it will align with other datasets. There are several data integration techniques where we supplement vector datasets with additional context or attributes. Common ways of doing this include attribute joins, where we combine data from a table to a spatial layer using a common field, and spatial joins, where we transfer attributes between spatial layers based on locational relationships. I will discuss spatial joins in the next video. We might simplify data. Simplifying data just means reducing the detail or complexity of geometries. Common preprocessing operations include simplification or generalization, depending on which software you're using, where we reduce the number of vertices in a feature while maintaining the general feature shape. This results in a decreased file size, but line and polygon features can become more angular. There is smoothing, which reduces sharp angles and jagged edges to create more visually pleasing, natural-looking features. We usually do this to improve aesthetics or approximate natural curves that might appear in rivers or contours or lakes. And then there's aggregation, where we group features based on spatial or attribute criteria to create fewer features or larger features, or both. We might extract data, where we extract a subset of data based on spatial or attribute criteria. This can involve clipping, which is an overlay operation I will discuss later, where we extract a portion of vector data that falls within a specified boundary. We can select features by attribute or by location. We do this oftentimes to export the selected features as a new data set. And then there's filtering, where we isolate the display of certain features based on conditions. Finally, we might convert data, which is changing the format or structure of vector data. This can include file format conversion, where we convert vector data between different vector file formats. For example, shapefiles, geopackages, GeoJSONs, CAT files, KMZ files, etc. There are geometry conversions, where we transform data between different vector models. For example, transforming a point shapefile or feature class to lines, or polygons to lines. And finally, there's data model conversion, which is the conversion of vector data to raster data or raster data to vector data. Preprocessing techniques are a critical part of vector GIS analysis. Good preprocessing can help us save time and reduce errors resulting from overlay operations. Join me in the next video where I will cover proximity operations using vector GIS data.